Try to imagine a group of animals so large, people have told stories about them for centuries. A group of creatures that capture our imagination with how awe-inspiring they are. Some even holding the record for the largest animals ever. Today, we'll be taking a look at one of these giants, the king lizard. On today's episode of Tate Minis, allow us to introduce you to Basilosaurus setoides. Despite the name and what the intro may have led you to believe, this animal is not a dinosaur. In fact, it's not even a reptile. Basilosaurus is an early kind of whale. It was only called Basilosaurus because the person who first found the fossils of it thought that it was a reptile, and was later corrected. Basilosaurus lived long after the dinosaurs in the late Eocene epoch, from around 41 to 34 million years ago, in areas ranging from the southern United States, Egypt, Peru, Pakistan, and more. Looking at Basilosaurus skeleton does, however, point to a trend that has occurred a few times in the prehistoric seas, namely that of serpent-like marine carnivores, specifically large predatory animals that have a long body and swim via tail propulsion. Examples of these serpents include early ichthyosaurs, such as Cymbospondylus and Himalayasaurus, and just about every mosasaur, from the relatively small Clydastes to the monstrously huge Tylosaurus and Mosasaurus. And, of course, the topic of this episode, Basilosaurus. Much like early ichthyosaurs and mosasaurs, Basilosaurus was an ambush predator that relied on its tail to build up speed and its flippers to steer its direction. Also like those two examples, Basilosaurus had a jaw full of devastating teeth. For a closer look at these mighty jaws, here's Russell Hawley.
So here's the skull of Basilosaurus, and to get you oriented, the eyeball would have gone right here, underneath that shelf of bone. One of the most interesting features of this animal are its teeth. In land animals, for example, this entelodont, the different teeth in the different parts of its mouth are different sizes and shapes for different purposes. In the front, they've got slicing incisors. Behind that, a pair of stabbing canines. Behind that, a row of shearing premolar teeth. And then in the very back, crushing molars for grinding and chewing. Well, if you're going to be living your life with your head underwater, it's not a good idea to chew your food, because while you're doing that, you drown. So modern whales and dolphins tend to grab their prey with their teeth and then just swallow it down whole. Here is the snout of a modern dolphin, and in contrast to the heterodont dentition of the entelodont, these have what's called homodont dentition. Every single one of those teeth is the same, from the front to the back, like a little row of golf tees. So what do we see in Basilosaurus? Well, here are the incisors, and they're shaped like stabbing pointed cones. Behind that is the canine, shaped, of course, like a stabbing pointed cone. And then here's the first premolar, and it too is shaped like a stabbing pointed cone. From the first premolar forward, those teeth were all pretty much the same. Then the second premolar is shaped like a double-edged saw blade. That's the right shape for chopping and slicing. That would have been useful for dealing with its prey. And then the rest of the premolars and the molars behind them are also shaped like saw blades. So from the second premolar back, the teeth are all pretty much the same. So what we have here is not heterodont dentition like you would see in its land-dwelling ancestors, and not fully homodont dentition like modern whales and dolphins, but rather something in between.
Basilosaurus' skeleton also leaves behind some clues as to what the early whale relatives looked like before Basilosaurus, and what whales would eventually look like after Basilosaurus. Looking at the backside of the animal's skeleton, we can see a pair of distinct, yet ultimately vestigial, back legs. Scientists have argued for decades as to what these would have been used for, but the most up-to-date hypothesis is that they're simply left over from when early cetaceans walked on land. For example, here's Pakicetus. Pakicetus was an early cetacean that lived on land and just went in the water to hunt, rather than the Basilosaurus, who spent all of its life in the water. If you take a look at the skull, you'll notice it almost looks like a miniaturized version of Basilosaurus' skull.
Another feature with which Basilosaurus is transitional is in the position of the nostrils. In land animals, like this dog or the ancestors of Basilosaurus, the nostrils are at the tip of the snout. And this is a very good orientation for an animal that follows its nose to find its prey. In Basilosaurus, The premaxilla bones are greatly elongated, and that shifted the nasal opening up onto the top of the skull. That's a very good place to have your nostrils if you're planning to be swimming and breathing at the same time. In modern whales, that's been carried even further. The premaxilla bones have elongated to the point where they almost contact the occipital bone at the back of the skull, and the nostril is above and between the eyes.
Basilosaurus is an interesting animal, almost resembling the mosasaurs of yesteryear, but still looking a bit like the whales of modern day. Basilosaurus is the perfect middle ground between these two. Not only does it look like an animal that we've known about and studied for hundreds of years, but it also looks like something completely unique. And that's what makes Basilosaurus so interesting to us at the Tate Geological Museum. We hope you've enjoyed this mini look at Basilosaurus setoides. For more information about our fossils and casts, be sure to scan the next code on your Tate Mini's guide sheet to lead you to our next video. See you next time on Tate Minis.